Hello everyone. So in this video we're gonna do our last module, which is module 4, about processing photographs in Agisoft Metashape, which is a very powerful photo processing software. So first of all, I need to make sure that you have all the right files. Okay, so for the software we're gonna use Agisoft Metashape, which is available in the drive. So you can just download the software here and install it using the guide that is in there. There's the installation guide in there. Okay, you just need to follow that. And second of all, make sure you have the modules. You can you can actually read what happened. And here I have I've added an extra document, I must say, about from the USGS about processing imagery with Agisoft, and this goes a lot more detail than the modules. So if you're interested in reading some of the details about processing, or maybe you need some explanations on when you're working on your analysis, for example, and this is I think this is a pretty great source. Okay, so after installing the software and we open it, here we have Agisoft Metashape. It should be like this, and first of all, make sure you click on help and activate product, and make sure it says this Metashape Professional is already activated. If it doesn't say this, then contact your assistant, because there's something wrong with the installation. Okay, then we need first, okay, it's gonna start. We first, of course, we add the photographs, which we're gonna use the same exact photos and data as in the module 2 PCI. So yeah, you should already have those. Okay, so add photos. So I'm gonna look for the files here, data photo, and then there are 9 photographs here of I think Aula Barat, I think in ITB. Open up. So there are 9 images, and make sure you save everything. Also, okay, you can look at it, for example, check if there's nothing blurry, make sure that the pre-marks here are well identifiable, and okay, that's enough checking. So we're gonna start with alignment of the photograph. So we have align photos here. So align photos actually does 2 things. So making the tie points, and then do the bundle adjustment, or in Agisoft they call it the estimation of camera position. They call it that. So but it's bundle adjustment. So here we need to set a few things up. So accuracy, we set it to high, of course, because we don't, there's the highest option, but don't use that. It's just a waste of time. So just use high. So generic per selection checked, reference per selection set it to source, and open the advanced tab here. So key point limit is 60,000. If you want to know what key point is, you can read the document that you can read this document. Okay, it's in there. Tie point limit 0. Why? Because we want as many tie points as possible, so we don't set the limits. We set it to 0. Okay, so you can ignore all that and select okay. We're just gonna wait, and this process depends on the performance of your computer. So here now it's matching points. So it's already looked for the potential tie points, and now it's trying to match those points to make up the tie points, because tie points need to be identifiable from multiple photographs, right? So now it's matching points. Now estimating camera location. So this is the bundle adjustment process. Okay, there you go. And I have to mention one thing here. So in the previous modules, we need to actually enter the photo coordinates, right? Remember that? But in Agisoft, you actually don't need to, because in each of the photographs here, sorry, where are the photos? In each of these photographs, they're actually in the metadata. There's actually an coordinate information there. That's it. Is already included in the photographs, and Agisoft can actually read those, so it makes life a lot easier for us. And now here we can see that we have around 24,000 type points. Just remember this. I think a lot more than what PCI can do. I think PCI at most like 6,000. Here we have 24,000 type points, but you can see here, if we set, wait a minute, now we set here and zoom out, the quality of these type points are a little bit messy. We have one right down there and here, and I think we have something like really high like this. It's a mess, so we need to filter these out later. But first, I think it's a great idea to put our control and checkpoints first. You can do this later, but I prefer to do it right now. So we have the GCP here, the gcp.txt. Okay, now so the coordinate system is not WS84. This is UTM 48 south. So this one, Omega Phi Kappa. Do we have it? No, we don't have that. Okay. So the delimiter is space because our file here is here is separated by a space. So we adjust that, and make sure to label the columns properly. For example, easting is the third column, so we don't want that. Okay. So in this case it's 1, 3, 2, 4, but adjust for the project, of course. And start import at row 1 because we have row 1 GCP1. Okay, and just press OK. Can't match for GCP1 entry, create the marker. Just say yes to all. Okay, the type points are gone. The type points are gone, but don't worry, because here there's actually something wrong. Here we have easting 107, which is not correct. 107 should be in degrees, so we need to set it in here, settings, and turn the camera preference and marker reference on. For the coordinate system, for the general one, we set it to 48s, but for the camera, this is not in UTM. This is in the normal WS84. So set it to that, and marker reference is in UTM, so we're correct. And while we're here, let's set up a few other things up. So camera accuracy is 10 meters, and for the degrees, I think 10 degrees is a little bit too big, so set it to 0.5. Actually the same settings that we use on PCI. Marker accuracy, this is 5 millimeter. I think this should be fine. And we press OK. Okay, now our type points have appeared back. Okay, so next, after we import our GCPs and ICPs, the next step is to actually mark those GCPs. So the way to do that is we click right on these and select filter photos by markers, and now we have the photographs that are potentially contains GCP1. So we're gonna double click on those. Oh, it marks it for us. So GCP1 should be right here, so we're gonna just drag it to the pre-mark here. Make sure it's centered, and we move on to the next one. The next one, or you can just press page down or the arrow key for that. there, page down, it should be already centered. So after 2 or 3 photos, it should be already pretty centered. Okay, it calculates it on the fly automatically. So there, this one's a little bit off. Okay, so this one doesn't actually have GCP1, right? GCP1 is right here, I think. Yeah, right here, right there. So we're just gonna ignore it and move on to GCP2. GCP2 will be in here on the road. Move into the mark like usual. So as already pretty close by the second photos, and by the third photo it should be like bang on center. Yeah, right. Okay, there's it doesn't appear there. Okay, just ignore that and move on. And yeah, no, it will be found there too. So at this point, you can, to just make sure, you can just right click again and filter photos again. So those photos that doesn't contain GCP2 will be removed from the list. And actually we need to check on GCP1 as well. It's still there, but it's fine. GCP3. Okay, drag it to the center. This is the second photo. By the third photo, it should be already pretty centered. Yeah. It's nowhere there. Okay, let's ignore that one. It's right on the edge of the photographs. So there, and there. Okay, we're done. Then GCP4. It should be pretty quick if you know your way around the mouse. But don't feel too rushed. Okay. GCP4. It's really far. Okay. Now it's centered. Okay. Now on why it took like 2 or 3 photos to make it centered is because remember the collinearity equation? You need to have at least 2 lines to determine a point on the ground, right? So yeah, we need to at least have 2 or better 3 photos to center the point. Now, okay, by the third photos, it's centered. Okay. And I think it's there. Okay, we're done. And then we move on to the ICP. ICPs are here on this photograph. Doesn't actually have a pre-mark, but it's gonna mark it anyway. So in this case, it's right here, but it's covered by these people. So the same as in the previous modules, if the point is not identifiable, and just ignore it. Okay, it's not. Okay, I think it worked in this. Okay, put it there. I think it's there. Yeah. Next. Okay, it's not there. No. There. Nope. And it's covered by this person. Okay, just ignore it. So we only have 2 points here. That's fine. So move on to ICP5. ICP5 is on the benchmark right here, on the center of that orange square. I think that's not quite centered. Okay, there. And here. There. And for because the point is this point is located like on a benchmark, so high up from the ground. So make sure you factor that in when you're marking these. So because you can see the parallax there, right? Like it looks like this post is like a little bit leaning to the side. It's not actually leaning, just the perspective. Make sure to put that into account. Okay. And finally, ICP6. I don't actually know where ICP6 is, so I'm just gonna assume it's right here, there, like right beside this white thingy here. Okay, so it's should be there. Okay, is there. It's not there. Okay, and okay, yeah, okay, we should be done by this point. And a reminder here, because these check marks here marks the what's being used for the calculation. So obviously we're gonna use the photographs for the calculation, and we're gonna use the ground control points, but we're not gonna use the checkpoints. Remember, the checkpoints are not in the calculation, so we need to actually exclude those. And I think we can view the errors here. Okay, so we have a lot of errors on the ICP6 because we don't know where it is. And the ICP5 too? Oh, it should be. It doesn't. It's not supposed to look like that, but I think we're fine. So make sure to save it. And I think a great practice would be like close to name the chunks here. So the chunks are there to I don't know how to say it, to make sure we have redundancy in the data. For example, if we align the photos, for example, and we remove some time points, we filter out some things. I think it's a good idea to have the originals, the unmodified ones, just for a backup. Okay, so in case we miss something on the step, we don't actually have to like do it all the way from the beginning. So we're gonna name that. I think let's say align photos, and we're gonna actually duplicate it. Save it first, and then duplicate, and check that. Okay, so we have copy of aligned photos. So now this chunk here is for backup. We're not gonna work on that. We're gonna work on the bold one here, on the copy. So just in case we mess something up, we don't actually have to like do everything from the beginning. Okay, now the next step is remember that I said that these points are still a mess. Okay, we have 24,000 points, and not all of them are good. So what we're gonna do is we filter out those points. So here, gradual selection. So we have multiple criterion here. So projection error, reconstruction uncertainty, projection accuracy, etc. You can look what these terms mean on the document, but we're just gonna do it here. So first we're gonna do reconstruction uncertainty. This is I think the geometry part of the error. Okay, and we're gonna set it to 10. You're gonna type it at 10. Okay, so we have from 24,000 points, we have 8,000 points selected. So the practice here is to if at level 10 we have more than half of the original points selected, then we need to actually increase the level. So there are less than less than half. But at 10 we currently have 8,000, which is less than half of the point, so we should be fine. Okay, so we have select OK, and this is the scary part, we delete those of the points, so press delete. Okay, now we have 16,000 points remaining. Okay, and so that we press this thing, optimize cameras. We select the default one, keep it on default, and select this thing, estimate type point covariance, and select OK. Okay, then a good practice is to look at the RMS here. So click on that and show info. We have RMS reprojection error of 0.16, which is already good, but we can do better. Okay. So after that, we select another gradual selection, which is projection accuracy. Now for projection accuracy, the guide is to get it down to 3. Okay, if your project cannot get down to 3, then as I said, increase the level. But in this case, the photos are good enough, so we have less than half of the points. So half of this will be 8,000. We have less than 8,000, so we should be fine. So okay, and delete again, the scary part. Okay, we have that, and again we optimize the camera. Select this thing, the star thing right here. Okay, estimate type point covariance, and select OK. Okay, and then we look at the RMS again. It's actually increased. Don't worry, it does that because at this point we don't actually like reduce the RMS projection on this step. We just remove the obviously bad points. So here we can see those points that are under here previously, they are now gone. Okay, now this is the optional part of the project. If you look at on the module, it's not actually there, but I'm still gonna do it because it's just to show you. So the third method is the projection error, and for this we actually selected to 1.3. Okay, so for reprojection error, the limit is actually not half but 10% of the points. So here we have 8,700 points. We actually at maximum need to select at 800 points, so we have way too much here, so we need to increase that to 800. Okay, that should be fine, and delete it again and optimize again. Okay, and we do it again until we get to 0.3. So 0.3, this is still more than 10%, so we need to increase that. Okay, this should be fine. Delete, and estimate type point covariance. Okay, optimize again, and I think it should be the final one. We do it again until we get to 0.3. Okay, now 0.3, and it's selected less than 10% of the points, so this should be our last gradual selection. Okay, delete and optimize cameras. Click that and this. Okay, now we look at our RMS. Show. Click right on this and show info. It's on 0.14, which is a lot better than we have previously. Okay, so those gradual selection that we do is to reduce our RMS to make a more accurate model of from these points. Okay, a good practice is also look at the errors here. Here we can view errors right here on the reference, view errors, and look at our errors in pixels. It should be so. A good practice is not to have the error in pixels more than 1 pixel. So we have all of them less than 1 pixel here, so we should be fine. And we look at our total error here. So the errors on the control points are minuscule, so it's I think 3 millimeters. It's okay. That's okay, 1 centimeter. Okay, we have 1 centimeter of error, and on the control points and on the checkpoints, it's I managed to do like 11 centimeters, which is not great, but we don't have much time here, so that should be fine. Okay, save that, and of course we need to rename this so we don't lost track of everything. I don't know. Gradual selection. Okay, and of course at this point we need to duplicate it again. So duplicate, so we don't lose our progress. Okay, and at this point we're the bundle adjustment, the camera optimization are done. So we have the hopefully correct type points here. So this is a really reliable points right here. So after this we can go on to make our products. We have on this module we have 2 products that we have to make. So we have the DEM, the digital elevation model, and the orthomosaic. So to do that we need to actually increase the number of type points first, because this is really far away from each other. It's really sparsely populated here. It's not gonna make a good model right here, so we're gonna have to increase the density. So we need to make a dense cloud, what it's called. So I think we're gonna rename it to products. So we need to make the point cloud, either point cloud or dense cloud is it's the name. So build point cloud, the quality should be set to high, and here on the advanced tab the depth filtering should be mild, because depth filtering is like a feature to smooth out any roughness in the surface. Okay, so for example, if you expect the surface to be smooth, you can get it to aggressive, but here we have trees and buildings and such, so we don't want those features to be smoothed out. Okay, we want this to appear, so we select mild. Okay, so here calculate point cloud and calculate point confidence for analysis later. Okay. Now because we only have like 9 photos, this should be done pretty quickly, but if you work on other projects where you have hundreds of photos, this can take a really long time. So the record that I've been working for is 2 days on this process alone. So yeah, that's why we only have 9 photos here. Okay. Now the first step that Agisoft is doing here is generating the depth maps. I think what it means is like it kind of interpolate from all these type points on what's the altitude of those points would be. Yeah, it is on the same lines as those, I think. Okay, why does it switch to GPU 1? Okay, so GPU 2. Yeah, this process actually run on your GPU, so the length of this process, the duration is would depend on the performance of your GPU. Now it's on the 6 out of 9, so we have 3 more to go. 7 out of 9. Okay, second to last. don't believe these numbers. Okay, it's you can see it as a guide, but not as like an absolute thing to refer on the length of your processing, because Agisoft lies. It lies a lot. Okay. Okay, now see here the generating depth maps, it's 72% done, but the overall progress here is like half of it, because after depth maps we have one more process here, which is to actually generate the point cloud, the dense cloud. Okay, generating point cloud. Okay, I think we're done. So we can look at the result here on products here, and double click on point cloud or dense cloud depending on the version. So here's the result. So from type points, from 7,000 points that we have filtered out to 4 million points. There's a lot more points here, and as you can see, the points are a lot denser. Here you can see the points here, but they're a lot denser. So yeah. Okay, so now we save it up, and we're going to build the dam here. Oh, actually, wait, hold on a second. Okay, sorry about that. We're gonna move on. So at this point, you can see here, you can already build a dam, but for this model we're gonna do an extra step actually. So, and that is to build the mesh. The mesh is the 3D model from the points. So from the points, we kind of build like a surface, like a 3D surface from the mesh. From the points. So our source data is it the depth maps? Wait a minute. I'm gonna look at the model for this. It's from the dense cloud. From the point cloud here. Okay. Service type. What is it? It's height field and height. Okay, set it to height field. So the difference between these two is that in arbitrary, you can have like overhanging buildings because the points are set arbitrary, but in height field it's only the height. You cannot have one point above another point, hence the 2.5D here. Okay, so it's like high, and let's take the face count to high, the advanced, I think just enable the interpolation and set it default. Okay, it's recommended to build depth of source data, but it's dense cloud here, so that's alright. Shouldn't be any slower. So here, triangulating. This is a grid interpolator, so it's doing some interpolations here. So we have here the triangulation, the faces. Okay, it should be done. So we can click the 3D model here, and yeah, we now see that it's now this is why it says 2.5D, the height field. Like this tree, even though it's a tree, is like it's an overhang, right? It's an overhanging object. Like there are objects below the tree, but here because we select depth field, it ignores everything below the tree. So yeah, we have like these towers here. So yeah, you might want to analyze that. Okay, and then our next step is to build the texture. Actually, I forgot what. Okay, select it to, I think this should be fine. Adapted orthophoto and blending. Enable whole filling. Texture size. What's the texture size here? It's 4096. Here we have a lot more. I think that's fine. Okay. Okay. So in most cases, you like if you only need to build an orthophoto or a DEM, you don't actually need to like build the mesh and the texture. The mesh and the texture is there to build 3D models and only for 3D models. So if you want to make a 3D visualization of the object, you want to make it look pretty, for example, do build the mesh and put texture on it. But if you only need the DEM or the orthomosaic, you don't actually need to do this, as we will see later. Okay. Okay, now blending textures. No GPU setup? Really? Why is there no GPU? I have a GPU. Okay, we're gonna fix that later. So the texture here is to like to put our photos on the 3D model. So we have the 3D model, right? But it's, as you can see here, the 3D model is really not that detailed in terms of color. It's like we have green here and brown there, but it's not really like, it's not photographic quality, right? So in this case, we put the texture, we actually put like overlay the photos on top of the models. Okay, what's going on here? Okay, now look, now it's actually look like a photograph, right? it's a lot better than our previous model. Which is great, because now we need to build the DEM and the orthomosaic. First, the DEM. Here, digital elevation model. Now the projection is UTM. Source data is now, because we already built the mesh here, we select mesh, but look here, you can also select point cloud. So this is what I said previously. You can build the DEM from the point cloud, but for this module you're going to have to do both. So build from the mesh and build from the point cloud, and you need to compare the two on your report. Okay, So first the mesh. Okay, okay, we have here the dam that was built from the mesh. Here you can see you can even see the little pathways here on the dam, which is neat. And you also have these ugly things here. You need to analyze on why that happened. Okay, and then after them we move on to the orthomosaic. We build it from actually from the dam. Hey, wait a minute, I'm gonna make sure I don't miss anything. Okay. Okay, I think you just need to save this first. So we have to export them to a TIFF file and save it. For example, like them from mesh, and click save. Okay. Export. Okay. That's okay. Okay. Now we built the dam again, but this time from the point cloud and not from the mesh. The point cloud here. Okay, and select OK. So you need to compare the two. If there's even any difference between the two. In my experience, there usually isn't a lot of difference. Like you can see here, like it's still pretty much the same objects. But okay, now we save that too. So this is them from cloud. Okay. Okay. For our next steps, we're gonna use a dem from clouds. Okay, because just because because we need to save time. Okay, so then our next step is to opt for orthomosaic. Here, click on build orthomosaic. Projection is already set on the dam or from the mesh. We're gonna build it from the dam first, okay? So here, refine seamless. What are the modules set? It doesn't actually say anything, okay? we're gonna leave it on default, but refine seamless is to, like, for example, if you had really like you have two photographs that are taken from two points far away, the objects on those photographs can usually appear like jagged, like you have breaks in the orthomosaic. And it's especially if, for example, one photograph is taken while the sky is sunny and another one while the sun is covered by cloud, for example, like it's suddenly covered by cloud. It's gonna mess on the colors, right? So that's what refined seamless is for. And enable hole filling, yes, we don't want any holes. And we're gonna ignore that one. Okay, from there. Okay, this might take a while. Really, 7 minutes? No, okay. Okay, now we have our orthomosaic here. This is our orthomosaic. We can set the points, the GCPs here, and we can look. There's still holes here and here, for example. There's holes here, and there's a wildly distorted view here. and you need to analyze on why these holes appear, okay? And you, in general, you need to look at the quality of this image and why do this. You know there's a pattern here, right? Like the more on the edge, the more outside the point is, like the more distorted the image would be. So I'm gonna give you a clue here. The best quality for any area photographs is between the control points. So if you draw a line from one control point to another, you're gonna have these like almost polygon like shape right here. So that is where the best quality would appear. So for example, here in this road, in this path, for example, here we have perfectly normal pathway, and here we have wild things right here, right? Like I don't know what this is. And this, I think, yeah, it's not the best quality out there. So yeah, you might want to put that on your analysis. So you need to save it as usual to export orthomosaic. So I don't know, ortho from, this was from there, and save it. You can use the default settings for this, or if you want a smaller file you can use JPEG compression, but I think this is already small enough. Okay, and now we make our orthomosaic again, this time from the mesh. Okay, now make sure the projection is correct, and okay. Okay, we're done. And one point here, one thing. So this we have here like 6.48 centimeters per pixel, and here are the 3.24 centimeters per pixel. These are the resolution of the products here. So the DEM is around 7 centimeters per pixel, but the resulting orthomosaic, because we use the actual photographs here, so 1 pixel here is about 3.24 centimeters across here. So that is the resolution of our product. So this is the one from the DEM, and also like just save it. Okay, don't forget to save, guys, and we export it again. So this one is ortho from mesh, and ooh, I don't have a big enough screen. Okay. Okay, now our products are done. Wait, I'm gonna search for those here. Here we open up the DEM, the ortho from DEM and ortho from mesh. For the DEM here, you notice like it's this white thing. Okay, like these files you cannot just open them up, because if you do, it's white. Okay, you need to open the DEM in a GIS software, for example in ArcMap or in QGIS, for example. Don't just double click it. It won't appear here. Okay, so this one is from the mesh and from the DEM. No, this is the DEM. Okay, wait, where is it? Order from DEM. Okay, this one order from DEM and order from mesh. Now you can see there are some differences here. For example, the holes are different. Here there are 2 holes, and here there are a lot more holes. Yeah, you and here in the building, on the mesh is like this broken building thing. I don't know why. Like you need to figure out why these things happen. You don't need to explain every holes, no, but you need to explain in general why these two results are different. Okay, so now our last step, at least on part one. On part two, we're gonna look at it on the lab, right? On like using a stereo view of the whole thing. But here, our last step is to export our report here, because science without a report is just playing around. So here, and select OK, and save it. For example, I don't know, report. Okay, now here is our report. Here we can see the survey data here. I think I'm gonna explain one by one on what these are. Okay, scrolling. So this is our area of interest here, and this numbers explain on how many photographs does each point appear in. So for example, this point here appear on 9 photographs, but for example this only appears on 2. So you can maybe you can kind of see on why these points outside are a lot less quality, right? So have camera calibration, have camera location here, the errors of the camera. This is the errors. It says the errors of the camera, but this is actually the errors of the UAV, of the drone that they used to take this image. This is the error of the GPS. We have almost 4 meters, actually almost 5 meters of error here. And the ground control points. The error on the ground control points is around 1 centimeter, and on the checkpoints is 11 centimeter. And this is for each points. Okay, ICP6 is full. Actually, it's already. Actually, let's go quite close. Okay, 4 centimeters. Considering we don't know where the point is. So this is the dam. You have the resolution and the point density here. So these are the parameters. I guess the metadata of this project. Okay. So you may want to analyze these. Especially analyze these errors. Okay. So the control point errors and the checkpoints error. Why are the numbers as such? Why is checkpoint error larger than control point error? That's an interesting topic to analyze, Okay, so I guess that's it for part 1, and make sure you do everything that I showed here, and see you on part 2 in the lab. Bye.